All right, welcome to another edition of Chemistry with your teacher, Mr. Whedon. Today we're going to be talking about how uh, we can see that light can be seen as waves, and essentially how electrons can play a part with essentially um, how lights work, how uh, colors come out of light, and all that. So, what we see is that electrons, after analyzing electrons, that they are available to emit light. And what we see is that light is essentially energy, or it's just the showing of some type of energy. So, what we can see is that when excited electrons drop to a lower energy level, that is when they do release light. So, again, when we see from different elements with different electron structures, behaviors, and all that, they're going to be able to rearrange the electrons in its atoms. So, again, when the excited electrons do drop a lower energy level, they are going to release some type of light. And so, in order for you to better understand this relationship and the nature of the atomic structure, we first need to understand the nature of light. And so, what light essentially is, it's a form of energy that exhibits wave like properties known as electromagnetic radiation. So, again, we'll be talking, this is kind of classic physics right here. What electromagnetic radiation is, it's a series of electromagnetic waves that travel in a vacuum at a speed of light. And again, that speed of light is going to be 3.00 times 10 to the 8th meters per second. So, again, essentially, we're just speed is another fancy or just a simpler term to velocity. And again, we see these different waves in a certain amount of, or in a different. Radio waves are an example of the different electromagnetic waves that we see. And again, radio waves are able to transmit different signals to each other. Microwaves are used. Infrared rays, visible light. So when we talk about visible light, we're talking about colors from red to violet. Okay. Ultraviolet rays, X rays, and gamma rays. So, again, some of the more powerful rays that we see. So, again, with ultraviolet rays, we got to think about UV rays, which would come from the sun. X rays are able to, again, look at bones without essentially getting rid of the skin around it. And then gamma rays are very powerful rays. Again, if you have seen the movie The Hulk, gamma rays was used to essentially create the Hulk. But again, if you try to do that now, you'd probably die. So again, in general, all these lights are considered to be electromagnetic radiation. So again, some are more powerful than others. We're going to talk about that soon. But again, it ranges from radio waves to gamma rays. So when we look at the electromagnetic spectrum, we see that the frequency of these waves are going to be very different. So what we see is that with a lower frequency, we're going to see a longer wavelength. So again, we look at radio waves, it's going to have a very low frequency and very low wavelength. But as we travel along the spectrum, what we see is that microwaves are going to have a higher frequency, again, lower than infrared, but it's going to have a higher frequency. And what we see is that the wavelengths are going to shorten up. So, again, we get to infrared and invisible. Now, we have this color spectrum here from red to violet. And as we see, or as we're going to talk about, that with color, it's going to range based on what type of frequency and what type of wavelength it has. So again, we see that red has a lower frequency but a longer wavelength than violet. And again, that's going to determine how light is going to bounce off. What type of frequency we see, whether it's a higher frequency or a lower frequency. And then with ultraviolet, again, you're seeing a higher frequency, shorter wavelength. X-ray, again, allows you to see the bones under your skin, right? And then we have the gamma ray, which, again, is going to be very high frequency, and it's going to be the shortest of the wavelengths. So the Roy G. Biv is an acronym that helps us remember the order of the visible light spectrum. And again, the visible light spectrum that we talk about is the red, orange, yellow, green, blue, indigo, and violet. And so it ranges from a frequency that is lower to a frequency that is higher. And again, as you go higher in frequency, you're going to see that the wavelengths are starting to get smaller. They're going to decrease. So again, as you approach violet, the frequency and energy of waves are going to increase. But because of that, you're going to see the wavelengths are going to decrease. So again, if you look at the spectrum down here, red is going to have the lowest frequency, and then it's going to be orange, then yellow, green's going to be right in the middle. And then again, as we go higher in frequency, we're going to have less of a wavelength. Light and quantized energy. So we were figured out by the 1900s that there was enough experimental evidence to convince scientists that light consisted of waves. So again, what are waves? There's two types of waves that we see. There's mechanical waves, which is going to require a medium to travel or some type of assistance. So again, we talk about air, water, or rope. And then there's electromagnetic waves, and there's no medium required. So again, if you ever skip rocks off water, you do ropes, and you can see kind of the waves as it goes through. What we see is that you're going to be able to see those mechanical waves. And again, the electromagnetic waves, there's no medium required because it's just the energy that comes off of the electrons. Again, dropping to that lower energy, releasing that light or electromagnetic wave. And so we look at the wave properties, and wavelength can be seen with the symbol of essentially an upside down Y, or what that Y, upside down Y, is called is lambda. And so the wavelength, what we see is going to be the distance between two equivalent points on a wave. So again, if we look at this chart right here, we see the top of each wave here. We see that the wavelength goes from the middle of this wavelength to the middle of this wavelength. And that would be the equivalent of 1 nanometer. So 1 times 10 to the negative 9th meter. Okay, so it's very small. We know that the amplitude is going to be the height from the origin. So the origin would be here to the crest. And this is going to involve the intensity of the light. Okay. So what we see is that the smaller the wavelength, the type of radiation is going to come out of it. Again, the smaller the wavelength, the more powerful the energy is going to be from it. So we look at a gamma ray, and it goes from 10 to the negative 12, which is considered a picometer. An X-ray can be either in nanometers or an angstrom. Okay, so angstrom would be 10 to the negative 10th, while nanometer would be 10 to the negative 9th. Infrared is going to be measured in micrometers, so 10 to the negative 6, and also in millimeters, 10 to the negative 3rd. Microwaves are going to be measured in centimeters, and then radios are going to be measured in meters. Okay, so these are the type of radiations that we will be talking about when we talk about electromagnetic radiation. So again, if we look at the spectrum from below, we see that over to the left is most likely a radio type of radiation. But again, as we go to the right, you're going to see that the wavelengths are going to shorten up, but the frequency is getting higher. So again, the wave properties that we are seeing is that frequency, or V, or nu, is going to be how many waves pass a given point per second. Okay, 1 hertz is equivalent to 1 wave per second. Okay, so 1 megahertz is equal to 1 times 10 to the 6 hertz. Okay, so 562 hertz is equivalent to 562 waves per second, which is also to 562 seconds to the negative first. So again, the amount of time it takes to get from the waves travel per second. And so assuming the wave passes in 1 second, what is the frequency of the wave to the left? And what we see is that most likely 1, 2, okay, if that was just in 1 second. Wave of nature of light. I'm going to stop the video here. All right, we will catch up next time with our discussion here. So go back, watch the video. This will help you with the homework and with the notes.